You have seen how the ECM processes input signals. Now let's look at the three most common types of output signals and the actuators that generate them. The ECM can act like a switch and turn actuators on and off. It can also control the amount of time an actuator is on or off. The ECM can supply either power or ground to a circuit. The ECM signal appears as a square wave on an oscilloscope. The waveform shown on the screen shows the ECM providing a ground to turn a circuit on. Actuators that use on or off signals include the canister closed valve solenoid, or CCVS, the variable intake valve, or the VIV, the malfunction indicator lamp, the MIL, control relays, engine, fuel pump, cooling fan. The ECM often controls output circuits by switching relays on and off. A relay has a control side and a load side. The ECM normally provides a ground to the coil in a control relay, and the other side of the coil is connected to battery power. Control relays are normally open type, which means that no current flows until the coil is energized. When the ECM grounds the coil in the control relay, the resulting magnetic field pulls the contacts closed and electrical power is supplied to the load side of the circuit. In the example shown here, fog lights. The ratio of the time on versus the time off during a specific time period is called a duty cycle. This control is continuous. This ratio is shown as a percentage. In this example, the output is on 70% of the time and off 30% of the time. This is called a 70% duty cycle. Actuators that use duty cycle signals include the idle speed control, or ISC, the purge control solenoid valve, the PCSV, and the HO2S heater. Duty cycles are expressed as a percentage, although fuel injector data is displayed in milliseconds. A 0% duty cycle means it's off. A 50% duty cycle is on 50% of the time. A 70% duty cycle is on 70% of the time, and a 100% duty cycle is on continuously. To get a better understanding of duty cycle, use the slider. How does the percentage change? How does the duty cycle affect the voltage? In order to operate properly, an O2 sensor must maintain a temperature of 698 degrees Fahrenheit, that is 370 degrees Celsius, or higher. When the exhaust gas temperature falls below this value, the ECM duty cycles the heater ground to warm the sensor tip to the specified temperature. To provide precise control of certain actuators, the ECM uses a technique called pulse width modulation. The ECM turns the circuit on and off, or modulates the circuit to change the duty cycle. Changing the duty cycle is called pulse width modulation. In the example shown here, you can see how the ECM gradually lengthens and shortens the on time. Actuators controlled by pulse width modulation signals include the ignition coils, cooling fan, electronic throttle, fuel injectors, oil control valve, and the alternator. Ignition coils transform 12-volt battery voltage into thousands of volts needed for spark plugs to create a spark to ignite fuel in the engine combustion chamber. Ignition coils are controlled by the ECM, which controls ignition timing. The ECM uses standard ignition timing data pre-programmed in the ECM's memory and modifies ignition timing based on engine load and engine speed as signaled by the crankshaft position sensor and the camshaft position sensor. To energize an ignition coil, the ECM uses pulse width modulation to repeatedly remove the ground connection from the primary coil. This induces a voltage in the secondary coil that is about 100 times the primary voltage. A fuel injector is a solenoid, which uses a coil to create a magnetic field. This magnetic field pulls a pintle upward, allowing pressurized fuel in small atomized droplets to spray out of the nozzle. The PCM controls the injector on time using pulse width modulation. The PCM varies how long the injector is on sequentially in order to deliver the correct amount of fuel into the cylinder. The ECM controls each injector by grounding the 12-volt control circuit. When the ECM de-energizes the injector by opening the control circuit, the fuel injector is closed and the circuit voltage will momentarily peak. Note that direct injection systems use 55 or 65 volts powered from the PCM to operate. The Electrical Power Management System, or EPMS, is used to control the charging system by the Engine Control Module, ECM, to improve fuel economy, provide a more stable power system, and improve vehicle component reliability. The battery sensor measures battery temperature, voltage, and amperage, and reports the information back to the ECM. The ECM okays the state of charge, or SOC, and engine load by monitoring throttle angle, vehicle speed, and engine RPM. Depending on the SOC, the ECM calculates the charging rate and determines the amount the battery will be charged. The ECM controls the alternator via the C terminal, varying the duty input, pulse width modulated, from the ECM to control generating voltage and current of the alternator. The ECM receives feedback from the alternator via the FR terminal's pulse width modulated output signal of the field coil operating condition. The ECM monitors this signal to determine the alternator's operation and electrical load.